Welcome to part 3 of our Kornucopia ML Quick Start training. This is the third of 8 videos for this course. Please visit our website at boditech.com for additional details on downloading the accompanying PDF course notes and other training files. We are now going to demonstrate importing a text file with Kornucopia's k_read text function. This function is designed to read all kinds of text-based files, including CSV files and other ASCII data files. So it is not intended to read Excel files, the spreadsheet itself. If you have a spreadsheet, generate a CSV if you want to use this function. If you want to just read spreadsheets directly, either use the wizard in MATLAB like I just showed with the process I just showed, or use MATLAB's functions to read directly spreadsheets. MATLAB does have some functions to directly read spreadsheets. In either case, you'll end up getting numeric data, and then you generate a k-units variable like I showed. So here, this tension test was originally derived from the spreadsheet, but it's been put out into a text format. So since it has a .txt file name in MATLAB, on the current folder, I could right click and pick open, and MATLAB will open it up into the editor of MATLAB just as a simple text file. So then we can see the nature of the data as it is in its natural text format. This is the same data that we've been manipulating, but now we're going to read this into Kornucopia, and Kornucopia will be capable to read all of it. So it'll read all this information, and then we can easily automate the extraction of additional information from this. So the way we do this in Kornucopia is we're going to use this k_read text function. So if we type that in the editor or in the command window and then click on it and hit F1, we'll get this quick help. And if we do that with this special function, there's an additional link right here. And if we click on that, that will get put into the paste buffer for us that we can paste into our script, this handy little template. So then you don't have to type all this. It'll automatically put that into your script. So I'll show this live here in a second and make a script. So actually, I will do that right now. So we'll move this over here. So what I would typically do is I would type k_read text. Whether I do that here or here, it doesn't matter. And I just got to put my cursor somewhere in this function name and hit F1. This is a Windows kind of thing. This also works with MATLAB functions to open up help on MATLAB functions, but this is opening up the help on the Kornucopia function. And it gives me a quick little description, and it has this little thing here to go get the template. So I do that, and it tells me the template is now in my paste buffer. So now I could erase this and paste that in there. I make this a little wider so you can see. It has typed this little template in for me. The comments here at the top are giving you a little bit of a description of how to use the template. I'm just going to demonstrate this, so I'm going to get rid of this, get it out of our way for the moment. So we are not. So when you do the import browser thing, you're browsing to get the file, and then you've read the data in. Part of the complexity with that is if you later want to use your script, you're like, well, where did I get the data from? And it was just somehow there, and then you have to rebrowse every time, or you have to have it give you a bunch of code to do all that in code. So in Kornucopia's functions, the general concept will be I'm going to put the folder name in the script and the file name. So if I go run this script next month, I know exactly where the data is because it was documented in the script. So in this particular case, the data is in this data files folder. And if I was in the script directory or the snippets directory where there's a snippet example here of this, I would be going up one directory, which is ... And then I would be up one directory, and then I'd be going down into the data files. So that's how I'm going to specify this data directory. If that was like confusing to you or not obvious, you could also always do something like this. You could open up a file browser, just a Windows file browser, and you go to wherever the data is, which on my computer here, it's in training. And here's the data. And I could literally take this whole folder name path and I could just stick it right here if I wanted to. I could do that. So now I've directly specified the path of where it is. I don't need the comment over here. So that's the path. Then I'm going to specify what file name in that path I want. So in this particular case, the file name is tensiontest.txt. So that's the file. MATLAB's full file function will take any path and a file name and properly concatenate them with the appropriate forward or backslash for your operating system. The data that we're going to be reading in, if I go to the data itself and import it here so we can take a look at it really quick. You see it's comma delimited. So in here, our delimiter is the comma. And then we have these additional arguments. What these additional arguments are asking for is, if I look at this file, where is like the top of the file starting? What am I searching for to find that? That's one of the things I'm looking for. Another thing I'm looking for is where is the kind of tabular part of the data structure? So what am I looking for to find that? And then if there was some ending thing to search for, what am I looking for to find that? And for each one of those things, I have an additional row shifting choice. So I can choose to look for things like I could say, find the word test type, and then go down 1, 2, 3 rows and start collecting the header text. And for the column name, I could say, I want to find the word time. The word time isn't anywhere here. If it was, time, comma, load, or anything like that as something to search for. And that's what we're going to be putting in these arguments. So for here, for the start string, I want to search for specimen dimensions, which just by fluke happens to be the value in this particular example or in the particular template. When I find that, I want to go down 1 row because I really want it to isolate this as the header information for me, because we're going to process that in a minute. And the column head string, I'm searching for the word time, which is right here. Kornucopia will smartly look on this row and 1 row under it to try to find the units. So I don't have to specify anything about that by default. And there's no ending things I'm looking for. It's going to read to the end of the file. And then all these arguments are fed in. And in our little example, we're going to call this raw 3. So when I do this and enter that, now the file's been read in. Not only that, if I hit dot, hit tab, and go to props, there's properties, and there's a bunch of stuff in a thing called user data. So remember, user data was a property where we could put all kinds of stuff in, and Kornucopia automatically will put a variety of things in there for us. Like one of the things it'll put in there is file info. It'll tell us what the file was, where it came from. So now when we do computations with this variable, and then I later save the variable and give it to somebody or whatnot, they can look here and find out where did this data originally come from. That will stay with the computations. Also in here is a thing called the dataset header, which was what we referenced here to go isolate. So Kornucopia automatically isolated this information. And this information in this example will be helpful for us because we're going to take width and thickness and get cross-sectional area, gauge length. We'll use that to divide into the extension to make a strain. And we could divide the load by the area to get a stress. So we can turn this force displacement curve, which is what you would naturally measure on an instron, and turn it into stress strain curves if we wanted to. So I've now read the data. So a really nice thing here with this function is it didn't read in just the numbers. It read in the numbers, the column names, the units, and even some of the header information. Not only that, if I look at the main header, as opposed to the dataset header, that's everything above the first header thing that I told it to find. It has all the information at the top. So really, we read everything in from the file. and stored it in our variable with virtually no effort from you, the user. Let's make this a little wider. Okay, so now I would like to get at this information. And what I really want to do is turn it into its own little table, because it has kind of like column names, it has units, and it has data. And so we can do that with the unpacked header function. So a simple way to do that might be to do something like this. And I'm typing something slightly different than what's in your notes, but it's pretty much the same essence. I want to make some temporary variable that. So if I execute that, temp is just this cell array of information that it already read in from the file for me. And now I can make a variable, we'll call it maybe params, and I'm going to use a function called unpack header. So with this unpack header function, it says, give me the header text information, which is the cell array, which is the variable temp. And then what is the delimiter for the thing to delimitate the kind of like units and stuff from the numeric part. And in this particular example, it's a colon. So now if I execute that, that smartly turned that text information into a computable entity. So then I could do something like this. I'm just going to quickly switch for expedience. I could then create a variable like area, referencing the width and the thickness columns out of the params variable, and then create a variable for a column of strain, that's the extension divided by the gauge length, and stress is load divided by this area I just calculated, and then convert the units of strain to that. And when I'm all done, I'll have a result like this, which looks really nice. Now, if I were to have continued to have done that live and typed these commands as they are, I would have had a warning sent to the screen. And the warning would be telling me a couple different things, that around a couple of operators, the output result did not inherit any properties or props from the input argument. So what's going on here is, like when we computed area, area is the width times the thickness. So when the area is computed, what should Kornucopia do for the name of the resultant column, which happens to have only one row in it? Should it make the column name be width times thickness? That would be kind of crazy. And like here, the strain column, should the column's name be ext/gauge length? It's not obvious. So Kornucopia has rules about when you do certain math that it can smartly make column names. And in other cases, when it says the column name is a little bit too complicated and I'm not going to inherit that or do it for you, and it warns you about that. It doesn't screw up the calculation. It just means that some of the output doesn't end up with any column name, like this area didn't have any column name associated with it. So in the help system, there's something about property inheritance that will describe a lot about this. So if this happens to you, I will show you, talk a little bit about why it occurs and also how to turn the warning off if that becomes annoying to you. And in fact, I'll just quickly describe this here. So the variables of KUnits data type have these various props, the description, column names, column comments, etc. And when you do some calculation like this, how does the software figure out how to fill all this stuff out? So it has a bunch of rules that are defined in that part of the help system that describe when it can do it and when it can't. And when it can't, it will give you this warning. So it tries to do it whenever possible, but sometimes the math is too complex and it's not really obvious what it should do. And so it will give you this warning. So if you get the warning once or twice, no big deal. If you get it a lot because you're doing a lot of math calculations and it's annoying, you turn it off with this simple setting. So you would just put this setting at the top of your script, and then the warning will be turned off and you won't see that. There are a few cases where you want to just get the numeric data from the K-units data type. You don't want the whole thing with the units and the column names and everything. You just want the table of data, the double type data that's underlying your data set. So things you might need to do that for is if you're calling a function that was not overloaded by Kornucopia and the function doesn't know what to do with the K-units data type fed to it. So in that scenario, you would want to extract just the numeric data out of the K-units data type. Also, if you're doing looping equations where there are really intensive calculations inside the loop, now Kornucopia has a lot of features to do this efficiently and smart, and depending on how you code the loop will depend also on your success and how fast it is. But there are some cases where the looping calculation will become slow because of all the unit manipulation. And in those kind of cases, you might want to get just the data, do the looping calculation on the data, and then recalculate or reformat a K-units data type after the loop. So those are a couple examples where you would want to get at just the data. So the way you do that is with the .data property. So here's an array with some data in it, right? So if I do a.data, I get just the numeric array of data. It's no longer a K-units data type here, this answer. It's just the numeric array. So you can do it like that to get all the data. You could do something like this, where you're saying, give me all rows in just the second column. Here you're asking for, in the .data, just the Excel column, because we have it labeled here, Excel. What a warning for you when you're starting to use Kornucopia. Don't just do .data every time you get some error and you think, oh, I just need numbers. Like if you do that and you retreat to that approach, you are really destroying a lot of what Kornucopia is trying to help you with, which is to make sure that you don't make unit-related mistakes, as well as you lose the ability, if you're just manipulating only numbers, you don't have column names to reference and things like that, your scripts become much harder to look at. You know, if you look at this example here, looking at the second column, I don't know what the second column here is. Here it's clear I'm like getting the acceleration column out of the data. So those are some things to be aware of related to manipulating your variables. Now, if you look at the variables that we have been playing with in this example, and we go look at the workspace, we would see we would have a bunch of variables. And in MATLAB workspace, it'll tell you kind of what's inside the variable and its class. So the Kornucopia stuff is all K-units class. If you have just an array of numbers, it might have a doubles class. Like here, this is a double, and this is a table. All the K-units ones, if you notice, the value inside it is just claimed as a 1x1 K-units, regardless of what's there. So raw1, raw2, and raw3, which are the three variables we just created, they are clearly not just a 1x1 array of numbers. They're a much larger array, just like this table is 976 rows by 3 columns, and same with the double version. But the Kornucopia version claims it's only a 1x1. That's because MATLAB doesn't know how to look directly into this. And so MATLAB views the variable as an entity or a thing. So it just says you have one thing there. So Kornucopia solves that problem for you with the .data size method. That method will give you the data size of a K-units type variable. So if I do something like this with 2 variables on the left, representing rows and columns, that could be A and B, it doesn't have to be R and C, that will give you what the data size is, 976 by 3. If you want just the rows, you would put a parenthesis 1. You want just the columns, it'd be parenthesis 2. So this would be the typical way in Kornucopia to get the number of rows and columns in a variable. Kornucopia has also something called Kornucopia-Compatible data types. So any data type that this works on in Kornucopia, A will be deemed a Kornucopia-compatible data type. So if I have some variable of type A and this successfully computes, A is deemed as a Kornucopia-compatible variable type. So what does that mean, or why is it helpful? So first of all, I can stick any Kornucopia variable into a K-units thing and it will come back out as the same thing. So that's by itself compatible. But then I can obviously put in arrays of numbers. That would be compatible. That would turn it into a K-units data type. It would be dimensionless. There'd be no units. But I can do some really cool things with strings. So like if I say A is some string and I do B equals K units of A, then that will produce 1 meter or 1 millimeter. Here I've defined some variable C as a string. If I feed that in there, that will turn that into a K units data type. I can even make a string that looks kind of like an array. Kornucopia will do that. I can just put in numbers and Kornucopia will then just have a number, but it will be a K units data type. What this is really helpful for is I can do this kind of thing when I need certain arguments on cornucopia functions that ask for a cutoff frequency or some other parameter. And instead of having to define the K units data type to feed it in, I can literally just feed in a string of this kind of nature. That'll be demonstrated when we get to the workshops tomorrow. Kornucopia will also take as a compatible data type MATLAB tables. This will be only true when the MATLAB table's primary data is of type double, or that it can be turned into a double. So the kind of thing that we showed before, you could feed that into a K units data type and or feed it into a K units function, and Kornucopia will interpret that. So this kind of thing will become evident when we start to put some scripts together and put some different things together. I want to make a couple comments about working with arrays. So here I'm going to depict some MATLAB arrays. So this is a 3x3 MATLAB array of type double. And here's a 3x3 MATLAB table. So in the MATLAB table, it will echo, if you echo to the command window, column names. But if there were units in the table, which you can define units, they're not meaningful. They're just things. MATLAB will not echo them to the screen. And if you open this variable up in the MATLAB editor, it won't freely show you the variable units there either. You have to right-click specially in the right spot to see them. The point being, MATLAB kind of views that as not super important, but does show you column names and the data. And if you make something like a cell array, which is a very powerful holding architecture in MATLAB, because you can hold various dissimilar things in the elements of the cell array. Here I have a 2x3 cell array, which has a char string in it, some kind of structure of who knows what's in there. Here's just a number. Here's a 3x3 double array. Here's another number, and here's a 2x1 cell itself, which could have who knows what in it. So this is like a general holder of stuff. Very, very powerful and very useful when you have to work with multiple data sets. Cornucopia arrays. Here's a 3x3 K units array that happens to have no units associated to it, so it's dimensionless, but this happens to be a K units data type. You can't necessarily tell that looking here just at the display, but that's how one would know units would show up. Here's a 3x3 K units array that has units but no column name. And here's one that has units and column names. So, and again, just to repeat, if you ever are manipulating stuff like this and you need to get at the data size, the size function is going to return a 1x1 because it looks at the K units thing as an entire entity. So you want to use the method of .data size, like b.data size for this thing, or d.data size or whatever, and then you will get the number of rows and columns in the array. With Kornucopia, because we have column names, we can manipulate rows and columns of the variable in ways beyond just the normal MATLAB approaches. So here would be normal MATLAB approaches to manipulate this array. And in this array here, I've taken raw3, which was the most recent interpretation we had read in. I've just reassigned it to a variable raw. So just to help distinguish when I further manipulate this. So I have this array. And if I wanted to say I'm interested in the second column, all rows, this would be normal MATLAB syntax for any array of type doubles or even a cell array. Kornucopia, this will work too. It will return for you the second column, all rows, but it will return to you a K units data type. So let me go and do this live so I can show you what this will look like. and we can compare. So I'm just going to bring this up to the top. And I'm going to say raw is raw _3. So here's our original data type. So I originally said, and I'll type it over here and let it echo the command window. So the first one I said was A equals raw, all rows, second column. This is normal MATLAB syntax. I'm leaving off the semicolon, so when I compute it, it'll echo. So when I compute that, Kornucopia will automatically give me the second column. But it doesn't just give me numbers, it gives me the whole K units entity. So it's still there, it's quite useful. And in fact, if I go look at the props of the user data stuff is still there from the original import. It transfers along. Kornucopia keeps track of all that for you. Let's put the raw back up there. Oops, let me put the screen up to the top. Let's echo the raw again. And now let's do instead, B is raw 1:10, colon. So what does this say? This says I want to go from rows 1 to 10, and then colon all alone means all something. So here it was all rows. Here, since it's in the second slot, that means all columns. So I execute that. And now I have the first 10 rows and all columns. Now only 8 show because by default, Kornucopia doesn't show everything. I could change that with this function here, making n to be 10 or 12, and then it would show me all 12 things if I wanted to. If I happen to have something less, like 7, then this extra stuff about this won't show because it's showing you all the data. But it's also saying there are some properties that are not being displayed, and it's showing you ways to look at them. The last syntax that was on that thing that I had presented is doing something like this. So this syntax would be, I'm taking the third column, all rows, and I'm subtracting from that the first row of the third column, and then I'm resetting that into the third column. So if we look at the third column of raw currently, it's like this. So now if I subtract this first value from all of them, these are going to become a bunch of zeros. So now they're a bunch of zeros. Now, I'm sure at much later values this becomes something because this is some useful data, and we will explore that in a little bit. Now, in addition to the normal MATLAB kind of syntax, we can also use cornucopia-related syntax. I can make a comp statement like this. Oops. So now the variable D is going to have the load column. When you make things and you don't put a 2-argument piece, but just one in here, and it could be multiple column names, it will assume by default it's always the entire column. So D is the entire column of load from the original data set. Let's type the variable raw again. Oh, I see I forgot to actually do the calculations to add the columns of strain and stress into the variable raw, like I did in your PDF course notes. Okay, let's switch back to the PDF course notes. What I just demonstrated live was making references into the cornucopia variable via numeric indices in a traditional MATLAB syntax approach. We can also use the column names of a cornucopia variable to reference into the array. When we specify just one or more column names, then all the rows are assumed to be requested too. The second syntax depicted is setting the variable E to all the columns ranging from load to strain in the variable raw. This type of syntax can come in handy with arrays of many columns. The last statement shown operates on rows 1 through 20 for the column named stress. The point of this is you can do stuff like you do normally in MATLAB, or you have additional abilities to reference by column names. And if there were row names, you could also additionally reference with row names as well. Now, let's say I've got this data set and I want to plot it. This would be the most simplest plot you would generate. So here we're plotting using the figure command to make a figure window. And instead of using the plot command of MATLAB, we use k_plot. The reason we do that is it will properly interpret all the fancy stuff that's in these variables. And here we're just referencing the extension and load column, and Kornucopia will generate this plot. It will automatically label stuff, including the units, and you have lots of controls over changing that. The plot function itself has over 70 advanced option choices to do all kinds of stuff to control the flavor of the plot. And in this little example here, we were just feeding in 2 columns of the data to plot it. And I've already stated here that it automatically used the column names and units from the data to properly label the plot for you. But you have full control over changing that in the call, and we'll discuss that more in a little bit. Okay, we're almost at the end of the K-units introduction. So I just want to make a couple of high-level comments about working with temperature and frequency. Temperature and frequency, you have to be a little careful. Kornucopia has a lot of technology to do the best as possible, but unfortunately, due to the nature of some of these things, it can't be 100% psychic to know exactly what you want. So with temperature, if you use units with Kelvin and Rankine, there's no issues because those are absolute temperatures, which mean they follow all the multiplicative rules of units. No issues, no concerns, everything works perfect. If you're using data that has units of Celsius and Fahrenheit, well, then there could be some complexities because the unit of Celsius and Fahrenheit could have an affine conversion required or not when you're doing manipulation of such data. So if you are doing manipulations that require affine conversion, then there's an additional offset in the formulation that converts the data from like Celsius to Fahrenheit. But if the calculations you're doing are non-affine, then there's no offset. So a simple example is if I have the temperature of boiling water is 100 degrees Celsius, and I want to convert that to Fahrenheit, that's an affine calculation. The conversion formula has the relationship between Celsius and Fahrenheit plus this offset. If instead I had a statement like the temperature delta from one side to another on a wall is 100 degrees Celsius, then the conversion to what is that temperature delta in Fahrenheit would not be affine. It would not have the offset, and you would actually end up with a different number than you would have for the boiling water case. So there's a bunch of advanced technology in Kornucopia's unit engine to handle this, but you do need to be aware. Frequency, Kornucopia also has capabilities to handle relationships of things like hertz and kilohertz and such, and inverse seconds and other forms of inverse time, and then radians per second when you're doing circular frequency kind of things like omega and things like that. There are some specific rules you have to follow because in the hertz to inverse second to radians per second, there's a 2 pi that's not easily tracked. Kornucopia does perfectly fine tracking it if you're dealing with these. But if you like to write a lot of equations that are things like sine of omega t and stuff like that, you definitely want to look at some stuff in the Kornucopia help system that talks about that. So there's specific help here that talk about it. And then there's a couple tutorials that talk about working with frequencies and angles and working with temperature. So if this stuff is stuff you're working with, please do look at these tutorials and section in the help system. That concludes part 3 of our Kornucopia ML Quick Start training. Please continue with the next video, part 4, via the link provided on our website.